I had a few kids come up to me and tell me their heights. And of course, the question they wanted to know was, who's tallest? It's a great question. And I suppose if they were with me in the room, we would just line them up, right? And we could do a direct comparison to see who is tallest. But what if they weren't in the room? What if all we had as a record of their height were these measurements? Could we use these measurements alone to determine who is tallest? To read these numbers, place value is going to be hugely important. And this decimal point is going to play a really important role. I mean, for some people, decimals kind of scare them. I'm sure it's not the case with you. But for some of them, they just want to almost ignore it and think of this as 16 meters and 143 meters. And I mean, those would be huge heights, right? Of course, it's ridiculous. That's not what this is saying. The decimal point is very important for us to understand the relative heights of these students. Why? Because the decimal is going to tell me where my 1 is. What's my whole? All right? This decimal says that it's 1 meter and a bit. 1 meter and some more. This is 1 meter and some more. This is 1 meter and some more. I'm going to pretend that I'm lying these students down against a wall. Their feet are going here, right? Their feet are going here. They've got their sort of knobby knees here, and their head's going to stick out someplace this way. And that's going to be the same for all three of these ones. Knees all the way through, their feet. They've got their legs here, their knees, and their heads. And the question is, of course, to find out who's tallest means whose head is going to be the farthest out this way. So let's begin. We've said, because we've looked at our place value chart, all these numbers are 1 and a bit. 1 and some more, if you will. So let's do that. Let's pretend this is my meter stick. And I'm going to actually tape this, because when you're measuring something, it's very important to eliminate gaps and overlaps. If you have a gap or you have an overlap, if I don't put things right up against the wall, my measurement's not going to be as accurate. So that's what I'm going to do. I'm going to just put tape here so that it doesn't slip. I'm going to do the same with this one here. Because I know all these measurements are 1 meter at least. Let's go to this one first. This says 1 meter, 0.6. What does 0.6 mean? So let's look at our place value chart again. Every time I move from one column to the one on the right, I'm dividing by 10. 1 is a tenth of 10. The same on this, and 10 is a tenth of 100. It's the same as I move into decimals. I'm going to take my 1 and I'm going to divide that by 10. And when I do that, when I take my whole and split it into 10 equal sections, I get a tenth. That's what we call this. 1 6/10. Now, you can see the numerator clear enough here. 6. What you can't see is the denominator of this fraction, because that's really what a decimal is. It's a fraction written in a different form. The denominator is hidden in the place value, 1 6/10 of a meter. So what does that look like? Well, I'm going to have to slide my piece over a little bit because I run out of space. I have 1 meter here, and then I have my second meter, but I have to take that second meter and subdivide it, don't I? Because it's not a whole meter, it's 6/10. This meter stick is already subdivided in that way. Here's 1 meter, here's 1/10 that meter, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, 10/10 gives me that second meter. Right? So where's 1 6/10? 1 1/10, 2/10, 3/10, 4/10, 5/10. 1 6/10 is right here. Does that make sense? You can see it. 1 meter all the way back here. That was where their feet were. The top of their head is going to get right here at 1.6 meters, right to there. Now, Let's think about our next one. 1.43. We've already seen it's 1 meter. How much more? Well, just like before, we're going to have to take our meter stick and subdivide it. And I'm going to tape it here so it doesn't slip around, so my measurement's still accurate. I look at this, 1, and I see 4/10. I know that same way I did up here, right? 1 and 4/10. 1, 1/10, 1 and 2/10, 1 and 3/10, 1 and 4/10. It's going to be here, but there's a little more, isn't there? The question is, how much more than 1 and 4/10? It's 0.03 meters more. What does that mean as a fraction? Well, when I go from my tenths column, let me move this down a little bit. When I go from my tenths column to my hundredths, again, I have to take that tenth here, and I have to divide it by 10. And when I do that, I get hundredths. 100, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 hundredths in 1/10. Or I could have looked at it this way. I have 100 hundredths in a whole, because that's what this means. It's 1 whole divided by 100. It's 1/10 of a tenth, or 100th of a whole. 10 hundredths, 20 hundredths, 30 hundredths, 40 hundredths. I want 43 hundredths, or 4/10 and 3 more hundredths. So here's 100, 200, 300. It's going to go right to here. Can you see that? 1 and 4/10 and 3 hundredths, or 1 and 10, 20, 30, 40, 41, 42, 43, 1 and 43 hundredths. Now let's look at our last one. So that's where this person's head would be. You can already see this person is taller than this one. How about my last one? What's that look like on our chart here? Well, as I said before, we have 1 meter. We know that 1 meter and some more. Just like before, the big question is how much more? So I know I'm going to have to take this second meter and subdivide it. I'm subdividing it, first of all, into tenths. And I find out they're 1 and 3/10. 1/10, 2/10, 3/10. 1 and 3/10. But they're 1 and 3/10 and a bit more. They're 1 and 3/10 and 4 hundredths more. So I'm going to take my next tenth and subdivide it into 10 smaller sections so that I have hundredths, just like I did up here. Divide my tenths into 10 smaller sections, 10 equal smaller sections, and they become hundredths. How many hundredths? I have 4 hundredths. So 1 and 3/10 and 2, 3, 4. 1 and 3/10 and 4 hundredths. But this person is funny. They really wanted to be very precise. So now what I have to do is take this next little section, that hundredth there, and what do I have to get to the next column? I have to take it and subdivide it into 10 equal parts, and I get thousandths. So what's that look like? Oh, ho, 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 ho. 1, 2, 3. Well, they've said 5 of these. So I know it's going to be halfway between, but I would have had to make it very, 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 very small. 10 of these little things. She counted 5 of them off. It would be 1 whole, 3/10, 4 hundredths, and 5 thousandths. Or I could have looked at it this way. How many thousandths are there in a whole? Well, there are 1,000 thousandths in a whole. There'd be 10 here, 20, 30, 40, 50, 60, 70, 80, 90, 100 here, 200 here, 300 thousandths here, 310, 20, 30, 40, 5. 1 meter, 345 thousandths of a meter. And that is where this person's head would reach up to.